Hi everyone, welcome to Chemistry Insight. In this particular video, I am going to discuss about Sandmeyer reaction. It is a versatile chemical reaction in organic chemistry which follows free radical mechanism, and here we can observe that radical nucleophilic aromatic substitution mechanism we can see over here. And what is the proof for the formation of radical over here? Detection of biaryl product is the proof for the radical formation. Actually, in Sandmeyer reaction, what will happen is the basic reactant we will be taking up with aniline or substituted aniline we will be taking up, and with this we will be treat with sodium nitrite and HCl, dilute HCl at 0 to 5 degrees Celsius, and in this we will be ending up with diazonium salts. Here I will be getting N2, here positive charge will be there and halide like this, and actually this step is called as Sandmeyer reaction, and in this case what we have to do is copper 1 state halide, we will be using it as catalyst over here, and finally we will be ending up with halobenzene. In this case we can see that here X is attached, where X can be chlorine, bromine or fluorine, correct? And not only this one, only halogenation, but we can do cyanation also. Cyanation is also there, and trifluoromethylation we can do, trifluoromethylation, and also we can do hydroxylation. We can produce, okay, in the first step halogenation is there. We can see over here from one aniline we can convert this particular aniline to BDC, that is benzene diazonium chloride, or simply halide we can take. We can convert this aniline to BDC. From this BDC we can go for these four types. We can prepare halobenzene or cyanobenzene, trifluoromethylbenzene and phenol. This is hydroxylation, means when this particular group will be replaced with a OH, it will become phenol, correct? Phenol also it can be correct. Phenol also we can be prepared. Since the benzene is there, benzene is actually it is not that much reactive because of resonance. Here substitution reaction is there, it will be more difficult in this case. That too it is electron donating group, here plus M effect will be there. Because of that, here double bond, partial double bond nature will be there in between the benzene and this nitrogen. And in this particular situation, when we have to convert this particular group into these four, it is based on Sandmeyer reaction, and it is very famous reaction, and I will be discussing with one example over here, and afterwards we'll discuss the detailed mechanism of this. Here I will be taking up with aniline, and here in the first step what will happen is we will be having sodium. In the first step, we will be having sodium nitrite, correct? Here I will be writing N, this is double bond O, and here O will be there like this. And in this one, we will have Na over here. This is positive charge. This is sodium nitrite. And when we treat with this with HCl, what it will become is, okay, I will be writing this one here nitrogen, and here O. We have to write like this. Here lone pair will be there, and here hydrogen. Just the positive charge will get exchanged, and here NaCl will be the byproduct. And in this case, HCl is there in more quantity. That means the lone pairs which is there on oxygen, it will attack this particular proton and it will get protonated as N double bond O, and here O is there and here H like this. And now what will happen, the lone pair present on this particular nitrogen is also there and oxygen, correct? Oxygen will donate lone pair like this, and finally water molecule will leave, and we don't want water molecule here, but actually the reagent is this one. This is nitrosyl ion. This is positive charge and lone pair which will be there on nitrogen as it is. And this is all diazotization, just I am showing for a reference, but actually from benzene diazonium chloride is the actual reaction. Now we generated this nitrosyl group, correct, nitrosyl cation over here, and now what will happen is this lone pair is there on this particular nitrogen, correct? It will attack over here and this one will move like this. Now we will get it as like this, and here nitrogen to hydrogen is attached as it is, positive charge will come on nitrogen and afterwards like this, correct? Now what will happen is it will, the positive charge is there on nitrogen will get neutralized, and finally we will get it as like this. Here nitrogen and one hydrogen is there as it is, then nitrogen double bond O, exactly like this it is there. Now what will happen, this particular lone pair on oxygen will attack this particular hydrogen and it will get like this. And in this case what will happen is, just I am showing for formation of BDC over here. Here nitrogen is there and here negative charge, and over here single bond nitrogen double bond oxygen with positive charge like this. Now this one will come like this and charge neutralization will happen, and over here we will be getting it as, here nitrogen double bond will come and nitrogen and single bond like this. Now again what will happen, again the same step, H plus HCl is there, since it will attack over here, and finally the lone pair which is there on this particular nitrogen will come like this and water molecule will leave like this. Then finally we will get BDC over here. This is benzene ring and here nitrogen with 3 double bond, 1 positive charge, and here we can use that HCl we are using, means here chloride is there. This is BDC. Now we'll see the mechanism of the Sandmeyer reaction. Here I will be taking up with, BDC, correct, that is benzene diazonium halide. Here nitrogen is there and triple bond and nitrogen and positive charge is there on nitrogen like this. And what are the catalyst we are using over here is copper, which is there in +1 oxidation state. If copper is there in +1 oxidation state, it will be having 2 electrons like this, and in the first step what will happen is this one electron will move towards the nitrogen like this empty orbital, and this 2 electron will shift like this. You can observe from this arrow here, single electron transfer, that is SET is happening over in this case, and here 2 electrons is shifting on the nitrogen, and we will be getting as, here benzene ring is there as it is, and here nitrogen, the positive charge will get nullified, and here I will get double bond, and this lone pair which is previously present on this particular nitrogen will be there as it is, and here I will be representing in orbital 1 electron. correct. Here this nitrogen will get the lone pair back, correct. It will be there like this, and in the next step what will happen is, if this particular copper 1, if it donates 1 electron, it will get copper 2, correct. I will be writing it as copper, which is there in +2 oxidation state, and it will be having only 1 electron, and it can be attached to this particular X. In this case, I will be taking up with chlorine like this, and this substituent chloride is there. The one chlorine and second chlorine, it will be attached to copper like this. Then in the next step what will happen is, this particular one electron, it will be moving like this, and here one electron, it will be moving like this, and here one electron, it will be moving like this, and here there will be a formation of bond between this particular carbon and this copper ion, and in the next step we will be getting it as nitrogen gas will be leaving here, and actual the product is, here benzene ring is there as it is, and here we will be ending up with copper, and here chlorine, and chlorine is there as it is, and here +3 state, correct. Since it donates 1 electron more, +2 is there over here, and it will convert it into +3. This is the intermediate in Sandmeyer reaction which are reported in recent publication. And here what will happen is, this is covalently bonded, this bond is covalently bonded over here, and whatever this particular bond is there, just I will be showing up with dot. This is electrostatic attraction, it is having a negative charge actually like this. And in the next step what will happen is, this particular chloride is there with electron, copper is not sharing its electron, it's just an electrostatic bond. This chloride ion will attack over here, and this 2 electron which will be present on this particular bond, it will go into copper. Then what will happen is, copper will get converted into +1 oxidation state, and we are actually the formation of this carbon and chlorine bond we can see over here. Actually chlorobenzene will form over here, and here copper, and with one halide, here this one converted into +1 oxidation state, and these 2 electrons I will be writing like this. Actually we can see over here, here we are taking as the catalyst, correct. Catalyst will regenerate after the reaction. We can see over here, this is the Sandmeyer cycle. And for the chlorination, this is chlorination, we used from aniline, we used sodium nitrite and HCl. And what is the Sandmeyer reagent we used? This is copper chloride, and we can use NaCl along with this. This is the reagent we can use in the Sandmeyer reaction. In the same way, we can use for cyanation, copper cyanide we can use along with sodium cyanide, like this we can use. And for trifluoromethylation, we can use, suppose if I will be taking with, to prepare that particular reagent, we will be using TMSCF3. TMS means trimethylsilyl. This is this particular group here, Me, Me and Me. This group I will be writing it as TMS, and when this one is treated with copper thiocyanide and with cesium carbonate, we will be ending up with copper CF3. This particular reagent, when we will use with BDC like this, here I will be writing N2 and Cl, here positive charge, negative charge, and here if I use this particular reagent, I will be ending up with trifluoromethyl benzene. This is here CF3 will get attached. This is trifluoromethylation. And in the next step, if I want to convert the aniline to phenol, I have to do first benzene diazonium chloride. I have to prepare first by diazotization, and after diazotization, I will be treating that with copper 1 salt, that is Cu2O, correct? Here it is there in +1 oxidation state. This is the first, and in the second one we have to eat with water, correct? Finally, I will be ending up with phenol. Here OH will be there as it is, and exactly like this, so many reaction we can able to see over here. Suppose for fluorination, here for to prepare fluorobenzene, here fluorine can be there. For that one, Ball-Schiemann reaction will is there. In that one, what we have to do is just we have to take the reactant as in Ball-Schiemann reaction. We have to take aniline as the reactant, and we have to treat with nitrous acid. And when we will treat with tetrafluoroborate, that is HbF4, we will be ending up with like this. Here benzene ring will be there, and here same like this, and the anion group is tetrafluoroborate, like this, negative charge. And when this one will get heated up, heat or light, that is H₂, I will be writing over here. Finally, here what will happen is this particular carbon and this nitrogen bond, it will break like this, and here we can see the intermediate is this aryl cation, that is phenyl cation. We can see over here, this one will abstract the fluoride ion from this particular moiety, and finally we will be ending up with fluorobenzene. This is the particular reaction. I hope this video was helpful for you people, and in the next video we will be meeting up with different name reaction. Thank you very much for watching.